This presentation is delivered by the Stanford Center for Professional Development.
So now it's time to talk a little bit about your next assignment. You just turned in your last assignment, you're like, but Aaron, oh no, it's not time to talk about the next assignment. I'm still working on the last assignment. Well, just pay attention. Here's what you're going to do for your next assignment. It's a little program called NameSurfer, okay? And the idea of this program is it turns out that the government actually keeps track of statistics of the popularity of names over time. Okay, so every decade when they do the census, they kind of keep track of the number of names, and they rank the top 1,000 names in terms of popularity for boys' names and for girls' names, and they actually make this data available. And we thought, wouldn't it be cool if you actually were to display names to the user in terms of how their popularity changed over time? So that's what NameSurfer does. Here's the program. What it does, it shows you the decades. You can notice that this is a graphics, or involves graphics, right? Has the decades from 1900 up to 2000, so relatively recent data up to the last census. And what we can do is we can type in a name and then click graph, and what it will do is it will show the rank of that name over time on a decade-by-decade basis. So let's try Fred, for example. If we graph Fred, you can see Fred real popular at the turn of the prior century, and then Fred just had this quick descent into oblivion, where now he's the 974th most popular boy's name, at least in the last census 2000. We can do multiple graphs on here, so if I type in someone else, so one thing that's also interesting is you'll notice popular culture comes in. So if I type in Brittany, the alternative non-traditional British spelling of Brittany, it didn't exist until 1980, in which case it totally shot up to like the top 100, and maybe with the most recent things that are going on, it's dropped a little bit. But through this whole region, what we have in our data, and I'll show you the data in just a second, is the Brittany did not rank in the top 1,000 until the 1980s, and then it jumped up. But because it started ranking in the top 1,000 in the 1980s, it still shows up in our data file because at some point it started ranking higher than that. Okay? And it turns out that there are some people who just have names that, well, are not so popular. So we do Meron and nothing comes up, because contrary to popular opinion, Meron is not in the top 1,000 most popular names. In a few years, you can change that if you have children. Your choice. Not that I would advocate it, man. It's a rough childhood. Like, Meron, doesn't that sound like moron? Yeah, I haven't heard that one in the last 2 hours. All right, I know. I'm just, rough childhood. Not that it affected me at all. So in terms of actually doing this assignment, you might say, oh, that's kind of interesting. Now, there's a couple things that are going on. You might look at that and say, yeah, I could do that, Meron. I can do that in the 0 to 2 hour category, right? Except for one little thing. And the one little thing is, check out this bad boy. Oh. As I resize the window, I will continue to resize the window until I get you in a hypnotic trance. Everything in the graphics display automatically resizes to display for that window size. Okay? And what you're going to find out today is how do you actually do this kind of thing to keep track of, as the window is resizing, how do you get events that come to your program that tells you, hey, some resizing happened, I need you to redisplay what's going on. The other thing that's interesting about this is I can, not only when I resize, it keeps track of all the information that's on there, Fred and Brittany. If I add someone else, like, oh, my son, William, who's always been a popular choice, just like in the top 10, dips briefly over here because maybe it was getting overused and then comes back up. Keeps them all, they're in different colors. The color sort of cycles, so if we add someone else like Ethel, Ethel, sorry, not so popular anymore. When the Lucille Ball, the I Love Lucy was on, or earlier, it was a popular time. It cycles through colors. Eventually, it'll go back to black. So if we put in something like Bob, it goes back to black. Then you'll see red again, then blue, then magenta. And that's all given to you in the handout. And if you hit clear, everything goes away except for the grid lines, and you can sort of, go again from there. Like here is George, and you can see George has a slight decline. He was 4 back here. And now he's like somewhere in the hundreds. It's okay if it goes off the window occasionally. Okay, but the resizing is kind of the key to this, and that's what one of the things we're going to look at today. Okay? So that's what you want to keep in mind for the assignment resizing, because the demo that's on the website, because it runs in a web browser, doesn't resize, and it sort of has that as a little warning down at the bottom. It just shows you how the program actually works, so you can try out typing in different names and see the behavior, but it doesn't resize because its size is stuck by the browser, and changing the browser window doesn't actually change the size of the applet. That's just life in the city. Okay? But that's the way NameSurfer works. Okay? So what we want to think about is actually building programs that have this kind of property. And to understand how programs that have this kind of property work, what we need to think about is something known as a component, and related to that is a container. Okay? So first of all, I'll show you all the classes in Java that pertain to components and containers. Not all of them, but a good number of them. Okay, so here's classes in the component hierarchy, and some of these will look familiar to you. Right? So programs, of which console program and graphics program that you've been using the whole time, are a JApplet, which is an applet, which is a panel, which is a container, which is a component. So somewhere all the way up the food chain, right? The food chain before, we didn't go that high. We just went up to applet when we showed you sort of this picture before. Turns out all your programs are components and containers. Every component is a container, or every container is a component. And so you may ask, well, what are containers and components? So the way you want to think about this is, at some generic level, a component is anything that can appear in a window. It's anything that can, in some sense, be displayed. So your programs are appearing in a window that's getting displayed. That's why they're components. Okay? Now, that also means that a graphics program and a console program are also components, because they're subclasses of program. Now, at the same time, there's a notion of a container. What's a container? A container is simply something that contains other components. So container just contains a set of components. And you might say, hey, Miran, that's really weird. A container is a component, but you're telling me it contains a set of components? What's that all about? And the simplest way to think about it is it's this. Okay? This is a component, this bag. It turns out this bag is also a container because it contains things. And it's perfectly fine for something to be a container and to also be a component. So here's what I mean, right? Your programs, as it turns out, are all components, which means they display in the screen, but they're also containers because your programs contain other things. For example, in the display of your program, it may contain a button.
That was easy.
Right? It may also contain, say, a text field. And the other thing that it may contain, if you have a graphics program, besides these kind of components, which buttons and text fields are also components, I'll show you an example of that in just a second, it may contain another container. And it's perfectly fine for containers to contain containers. As a matter of fact, you've been using them for the whole time. Your graphics program, especially if you have a graphics program that has some interactors on it, it could have buttons, it could have text fields, it could have a G canvas. And G, guess what? A G canvas is a container and a component. Because it's a component, it can be contained inside some other container. And because it itself is a container, it may have certain things in it. Oh, like here's our friend, the frog image from the midterm. Yeah, that was just something that was in another container. Okay? So there's no reason why something that is a container can't be a component, which means it can be contained in some other container. That's fine. And all containers themselves are components, so they can be stuck in somewhere else. Okay? That's the basic idea. It should just think of its bags, and you can put bags inside of other bags, and bags contain things. So even though you see the hierarchy this way, the concept itself is actually not all that difficult. Okay? Now the thing you want to think about this is, I just mentioned to you, your programs are actually components and containers. Gcanvas is a container and a component. But components that we talked about before, JComponents, like our friend, say, JButton, you actually saw this slide a couple classes ago, JButton or JLabel or JComboBox, all these things you saw before are actually JComponents. They all are subclasses of JComponent, which means by being subclasses of JComponent, they were also containers, strangely enough, and they are also components. We just think of them generally as components, and we sort of put them in other containers, like we put them inside the display for a program, and that's its container. Okay, but that's the general idea that's kind of going on here. So when you want to think about containers and components, what you also want to think about is that these components themselves, before we thought about like action listeners, right? Like something happens, like I click on some component and some particular event happens, like I clicked on it, something like that. We can think of the whole component as also listening for other events, because a component is something that can display stuff on the screen, stuff can happen to be components, like they can be resized. And when a component's resized, some event can get generated and sent to that component that says, hey, guess what? You got resized. You need to do something. Like the canvas that shows all the graphics, it can get some event that says, hey, canvas, yeah, you were just resized. Do whatever you want to do. Up until now, you didn't do anything. Someone came and resized your canvas. You said, yeah, you're resizing my canvas. All the pieces I have in my canvas stay where they are. Nothing's changing. Now what you're going to get is the ability to have the canvas be told, hey, you got resized or something else happened to you. You can respond to it however you want, which means you can redraw everything that's in your canvas so that, for example, you can have all the layout come out just fine when people resize your window. Okay? So what does that actually mean in terms of these components and containers? What it means is that we can have listeners in the same way that you kind of thought about listeners for mouse events and listeners for JComponents. You can have listeners for components, okay, like we talked about resizing the window. Now here's a little simple example of something that can go on with one of these components. Okay? So I'll come back to Eclipse. I'll run a little program here. I got to compile. And I'll show you the sort of a very simple program that makes use of this concept of a component having a listener and being able to get certain events. Okay? So it's just called my program. And here's what my program does. It draws a square. That's all it does. It draws a filled-in square. And you're like, why are you showing me this, Maron? I could have done this in the first week of class. And I would say, no, you were doing Carol in the first week of class. And then you say, no, I could have done this in the second week of class. And be like, okay. But could you do this? Oh. Yeah, when you did this before, that square just stayed where it was and the size of the window changed. Nothing happened. Now the square always remains in the center of the window no matter how I resize the window. Super small. It's still in the center. Super big. Another one of those things good for about 20 seconds. Okay? But that's the idea. How does it know when the window is getting resized that it needs to do something to update its display? Okay? So the way this is going to work in terms of having a square that recenters itself is we want to think about having a program that is a container. Okay? And so up until now, you had console programs and graphics programs, and they were containers. And what they did for you automatically for a console program, it created a console for you and put it in your container so that anything you printed showed up in that console. And for a graphics program, it created a GCanvas for you and put it in the container, and anything you drew showed up on that canvas. And now what you're going to do is you're going to create your own program that's not a graphics program or a console program, but to which you're going to create your own canvas and add it. Okay? And so the way that would look is you would say something like public class and then give it the name, whatever name you want. So I'll call this my program. And this is going to extend just the generic program. It's not going to extend console or graphics program. It's just going to extend program. And so inside here, it's still going to have some init method like you've come to know and love in other programs. And inside init, what we're going to do is say, I'm going to create a new canvas. But the canvas I'm going to create is a canvas that is a new object I'm going to create myself, that I'm going to define what that canvas is, rather than the basic G canvas. So I'm going to call this my canvas. I'm going to do top-down design. My canvas is a class that doesn't exist yet, right? It's not a built-in class. It's my canvas. It's something I'm going to write the code for in just a second. And I'm going to have some object called canvas, which is of type my canvas, and I will create a new my canvas. And at this point, you should be getting a little bit worried unless you've internalized top-down design. If you've internalized top-down design, you say, yeah, I'm just going to go create my canvas when it's time for me to write that code. For right now, I'm just going to assume it exists. Okay? And then what I'm going to do is I'm going to add this canvas to my container. When I do an add of something that is a component, in this case, canvas will be a component. You'll see why it's a component in just a second. It says, hey, program, add this particular element to yourself. And program says, hey, I'm a container, right? I don't already have a canvas. I don't already have a console, but I'm a container. You're giving me a canvas. The canvas goes up in my container. And if it's the only thing in my container, its size will expand to fill up the whole screen. Okay? Kind of like you saw last time. And that's it. So what I've done in this program is said, hey, I'm going to have a program. I'm going to create a canvas where all the action is going to happen in that canvas. And I'm going to add that canvas to the display. And then I'm going to let the canvas do all the work. Okay? So any questions about this, just creating the canvas? So now we can actually sort of define what is my canvas. And I'll show you that on the computer because it's a little bit more involved. Okay? And you don't need to worry about writing this all down. Actually, on Friday, I'll give you a handout that has all this code in it. I just didn't want to give it to you now because then you wouldn't pay attention to what's going on the screen. Okay? So what I'm going to do is I'm going to have a class myCanvas. And myCanvas is going to be a gCanvas. So it's going to be an extension of a gCanvas. It's going to extend a gCanvas. So all myCanvases are gCanvases. Because it's a gCanvas, that means it's a component. Because it's a component, I can add it to a container. So that's why add works there. Okay? Now, what am I going to do with this thing? The other thing I want to do is I want to say, hey, this is a component that's going to listen for stuff. And so the way I do this is rather than doing add mouse listeners like I did before or add action listeners, which look at actions of things like buttons, the way a component actually listens is it implements the component listener interface. So when you want to have some component that is actually going to get events that it's listening for, component events, the way you do that is when you create the class, you say it implements component listener. That's just the way you say it. So it's going to implement the interface. There are some set of methods it needs to provide that implement that interface. And I'll show you the list of methods real quickly. They're just down here. Okay? These four methods here, component resized, component hidden, component moved, and component shown, are the methods that comprise that interface, the component listener interface. So anything that implements the component listener interface needs to provide these four methods. In a lot of cases, you won't necessarily care that something happened. And so, for example, if the component is hidden, which means some other window comes over it, the component is moved or the component's shown, you're like, yeah, whatever, like I don't care. Those are good things. I need to have methods that correspond to those things because in order to implement the interface, I need to provide methods that correspond to all the methods that the interface is expecting. So I need to have these. But in 3 of these 4 cases, I'm not going to do anything, right? It's just open brace, close brace. Someone comes along and says, hey, guess what? You were occluded. Someone hid you, so your component's hidden. And you're like, yeah, that's cool. And you're like, aren't you going to do anything? No, I like hiding. And it's like, oh, look, your component was moved. Someone came along and moved your window. Aren't you going to do something? And you're like, no, I'm cool with that. That's fine. You move me, right? I won't get into the music. But if you can think of that, what that reference actually is, it's not that difficult. Louie. Component shown, again, nothing. So the only time we actually care about doing something is when we're resized. Because when we're resized, we want to say, hey, our component was resized. Let me move that square to wherever the new center is of that window. Okay? So whenever my component's resized, I'm going to get the component resized method called, and I'm just going to call a method called update. And what's update going to do? Update's right up here. All update says is remove all. So who's the remove all message being sent to? It's being sent to myself because I'm not specifying any particular object to send this message to. So when I say remove all, I'm sending it to my canvas. Well, my canvas is a gCanvas, which means remove all removes everything that's on the canvas. It clears the canvas, which means wherever the square was before, it just got cleared. Okay? And what I'm going to do is I'm going to add some rectangle, and I'll show you the rectangle. It's pretty simple. So what I have is I have a private grect that I call rect. It's just going to be some private variable that I keep track of. In the constructor for my class, what I'm going to do is before I tell you what add component listeners this does, I'm going to create a new rectangle whose width and height are whatever I specify as constants, is the box width and boxed height. They're just constants, not a big deal. And I set it to be filled. So what I get is a filled square. I've created this rectangle as a filled square. I haven't done anything yet with it other than create it. But I've created it and I have some variable rect that refers to it. So all update does is it says, hey, you know what? Remove the square if it was anywhere on the screen before, and now add that rectangle back at the center location of the square, right? What's the center location at this point? You should be real good with figuring out how to center stuff on the screen. You take the width of the screen, subtract off the width of the object you're displaying, and divide by 2. That's the x location. You take the height of the screen, subtract off the height, and divide by 2. That's the y location. And this get width and get height will get the current size of the component, which means when the component's been resized, this update method gets called, it clears the screen, and it gets rid of the old box and draws a new box at wherever the new center of the screen is, because this gets called, which means update gets called after the component's been resized. Okay, so that way it's going to redraw the square always in the center of the screen. The only other thing about this program that you need to know is in the constructor for myCanvas, My canvas implements the component listener. So you not only need to say, hey, I implement the component listener, but you need to actually say, hey, you know what? I am a component listener, so add me to the component listener list. And the way it does that is that you just call add component listener, and you pass this, which means myself. So somewhere I say, hey, you know what? Add me to the list of component listeners. I'm giving you a parameter to myself so you know who I am. So when something happens to me, you can call my component resized method to get resized. Okay? And that part up there, that add component listener, is just boilerplate. But it's going to, for example, show up in your name surfer assignment. Because guess what? In your name surfer assignment, when your component gets resized, you're going to do something very similar to this. You're going to find out what the new dimensions of the screen are and redraw everything that should actually be on the screen. Which means you need to have some way of being able to keep track of the stuff that's on the screen. Okay? So any questions about this? Alrighty. So that's the basic notion of this idea of a component listener. Okay? And what we want to think about next is, how do I create a larger program with these kind of things? So this is just the simple hint. Now I'm going to give you something that's even a bigger hint to what's going on in NameSurfer. And so what I'm going to do is, you know, one thing that's real popular these days is kind of like music, right? Like online music and albums and the whole deal. And so what I want to do is implement a program that keeps track of data related to music. And I'm going to have a little music score. Or music store as opposed to a music score. And the basic idea here is a lot of what, well, I shouldn't say a lot, but so far you did a lot of games in this class, and games are great, and I totally encourage games, and I'm a big fan of games. I got into computer science because of games. It's a good time. But a lot of what computers are actually used for as well, like when you go to some .com site or whatever to like buy music, and I won't name a particular one because I might get sued. You know, it's doing data management, right? For them, when you go to their site, all they really care about are what are the songs they're providing. Do they, particularly if you're buying, you know, like a physical CD, do they have it in stock? Sometimes you just get stuff, you know, downloaded that's all digital. And the other thing they worry about are, you know, stuff like prices and inventory management and stuff like that. But that's really all that whole site is doing, is it's doing management of data. So we're going to write a little program that does management of data. And the basic idea here is someone comes along and gives us a data file called music data. And the idea of this data file is it's a very simple format. The basic format, I'll just draw it out here, is every line of the file contains information about one album that's in the inventory. And the basic idea is there's a bracket, there's the name of the album, right? We can't just use spaces in this case because there might be spaces in the name of the album, but we kind of assume there's no brackets in the name of albums. So there's the name, then there's a space in a bracket, and then the band's name that actually produced that album. And then there's an integer over here, which is the number in stock of that particular album, right? So we have 10 copies of Snakes and Arrows. Any Rush fans in here? No one? There's like 2? Times have changed, I gotta say. All right. I know there's not going to be any fans of this. Dawkins? Anyone? Yeah, I would not advise it. And Smashing Pumpkins. There might be a few. Yeah, it's a good time. It's a good time. Old stuff a little better than the new stuff, but that's not important right now. What is important is that we're going to have some data, and our program is basically going to manage this data, right? It's going to read in this data file and allow someone to ask questions about, for different kinds of albums, do we have that album in stock, and how many of that album do we have in stock, and do some nice little graphic display on it to make use of some of the graphics concepts that we've actually shown. Okay? So what I want to do in this program, let me actually show you the program in operation so you can see what's kind of going on with the whole display and resizing the display and why it's the coolest thing ever. So when we run a program, I'm just going to call this program Music Shop. Okay? When I run Music Shop, what I get is basically a blank screen. It asks me for an album name. And so I can come along and say, oh, do you have any copies of Plans by Death Cab for Cutie? Any Death Cab fans? Yeah, strange name for a band. What it does, you might be difficult to see, but it writes out album Plans by Death Cab for Cutie, 10 in stock, and it writes out little squares to indicate that there's 10. It writes out 10 squares, and you might say, okay, Maron, yeah, that's not the greatest display in the world, and it's not, right? It's the display I wrote half an hour last night. But what's kind of cool is, oh, look, it centers this way. And here's the other cool thing. Look at the size of the boxes. Ooh, they get smaller and they expand. So they always have the same spacing, but as I expand out or get smaller, they resize. The fonts don't resize, they just recenter. I could, for example, put in perhaps one of the greatest albums of all time. So by Peter Gabriel, there's 20 copies in stock because everyone should own a copy. And if you don't, that's okay. It's perfectly fine. And sometimes I might type in a band that doesn't, or an album that doesn't exist. Like I might type in, I don't know, Cow, which is, there's probably an album out there called Cow. I don't know why I always pick Cow, I just do. In which case, everything just disappears. Like, we don't have that in stock, just back off, man. So that's what's going on in this program. So we need to be able to resize the bars, and we need to vertically center the stuff that we display in the screen. How do we actually do that? Okay? So one thing we want to keep track of is you want to go back to the data, right? You actually want to say, if I need to do this, in order to display anything, the first thing I need to do is figure out some information about the data that I want to store. So what data do I want to store? Well, I probably want to store some information about albums, because that's what I have in my data file. So if I think about my data file and wanting to encapsulate all the information about one album, okay, I want to do something on a per album basis, because every album is going to have, for example, an album name. It's going to have some band name that produced that album, and some number that's in stock, like num stocked. Oh, and this is a string, and this is a string, and this is an int, and it's good to put semicolons at the end of them, and it's probably a real good idea to take this whole thing and turn it into a class that's going to encompass all this. Because what I want to have is modularity in terms of my data. If there's a whole bunch of data I want to manage, the first question I want to ask myself is, what's the basic element of data that I want to have? In this case, the basic element is one album. I'm going to have a bunch of albums, but the basic idea is one album. And an album is going to contain an album name, a band name, and a num stocked, which are, for example, going to be private fields of that album. Okay? So one of the things I might want to do, and I'll just show this to you real quickly, right, is I would create album.java, which is just some class. It doesn't extend anything, right? It's just going to be a class to keep track of data. And what it's going to do is it's going to have some private instance variables, album name, band name, and num stock, that's going to keep track of the information for one album. And then it's going to have some other methods. One of the methods it's going to have is a constructor. What does the constructor do? It says, hey, you want an album object? Give me a name for the album, a name for the band, and the number stocked. I'll set all my internal variables to those things. I'll do a little annoying pop-up on the screen. And what you'll get from your constructor is you'll get an album object that encapsulates that information. Now, I made all this stuff private, right? Album name, band name, and num stock. Because what I want to do is when you create the album, you say, hey, this album's in stock. I don't want you to go back and say, hey, no, the name of that album changed. That's not what happens, right? When an album's released, the name stays the same. Generally, we won't talk about special cases, all right? So in order to get the information out of an album object, I need to have some getters. I could potentially have setters as well, but here I have some getters. Get album name, get band name, get num stocked. Pretty straightforward getters. You've seen getters in the past. Not a whole lot of excitement going on there. The only other thing I might add, which I told you in the days of yore that you didn't have much need for until now, is to have a toString method just returns a string representation of that particular object if you ask for a string representation. So it just writes out quote album name quote by band name colon the number stocked in stock. So it can return to you a string that basically has all the information about the object in some nice little display format. And that's the whole class. Okay? This is just a simple class that keeps track of information about one album, because we're going to have a bunch of albums that we want to keep track of. Okay? So now that we can keep track of information about one album, it kind of brings up a deeper question. The deeper question is, we don't want to keep track of just information about one album. We, in some sense, want to keep track of a whole set of albums, a database of albums. And what we want to do, if we think about a running program, so I'll go back to the running program, is we want to allow someone, given a particular name for an album, to be able to go look up all the information on that album. So the way you want to think about it is, given a name, I want to go and look up the record for that particular thing. Okay, and this happens all the time. It happens with your student ID records, right? Except we don't do it by name. With your student ID records, we say, given your Stanford student ID, let's go grab a record of all of your information. It's exactly the same problem. This is just a simple version with albums. Okay? So if we want to think about having some mapping where, for example, from some name, we can go get the whole information about that record, what kind of data structure might we think about? What kind of thing that you've seen before? Ah, yeah, the whispered hash map. Could it be the hash map? And in fact, yes, it could be a hash map. And the thing you want to think about with the hash map, that's very concentrated. It's a low variance event. We'll just kind of pepper the whole crowd. You're like, oh, everyone. Yeah, it's early. It's before Thanksgiving. Have some sugar. We can think about a hash map. Now, when we think about having a hash map, right, suddenly everyone wakes up. It's like, food, I know, sometimes. Anyway, hash map. What are we going to map to? What are going to be the two types that our hash map is parameterized by? What's the first type? What are we going to look things up by? What's the key? String, right? We're going to look things up by the name, which is a string. When we look something up, what do we want to get back? An album. So what we're going to have is a hash map that maps from strings to albums. And I think someone said album right over here, although I think I missed you. Sorry, I missed you again. So the basic idea is, given some name, I'll go look up the whole album. And at this point, you might say, but Marin, isn't the name inside the album? Yeah, that's fine. It's in your student record, it also contains your student ID and your name. We just happen to look it up by your student ID. And it's the same thing here. The user is going to give us the name to look it up. When we go look it up, it's fine if the name's also contained in the album, but there's a whole bunch of other information we care about there as well. Okay? So if we have some hash map, we'll call this particular hash map inventory. And we might say new hash map that's going to map from strings to album. And there's the constructor. And so that's how we might actually create this particular hash map. Okay? So once we have this hash map, right, if we're going to have some object inventory that's a hash map of all these things, we need to load it up. We need to say, hey, all my data is actually sitting in a file somewhere. What I need to do is read the data in from the file. As I read the file line by line, every line I'm going to create one of these album objects, because every line is information about one album. And after I create this album object, I'm going to add it to my hash map. And so my inventory is going to be all of my albums mapped to by their name. Okay, any questions about that basic idea? So let me show you the code for that. What does that actually look like? So here's album. You saw album. What I'm going to have is I'm going to have my music shop. What's my music shop going to do? Before I show you everything else the music shop's going to do, it's going to have this hash map. It's going to have a hash map for inventory that's a map from strings to albums, and it's initialized just the same way you saw over here. And the way I set this up is I'm going to have some method I'm going to call called load inventory. What's load inventory going to do? It's going to have a buffered reader, because I need to open a file, and I'm just going to hard code my file. It's called musicdata.txt. I go and I read the file line by line. So I grab a line from the reader. If it's the last line of the file, right, or there's no more lines left in the file, I'm done. Same thing you did with file processing before. If there is a line there, then I'm going to write some method called, it's top-down design, called parseLine, which says, hey, let me give you the string that I just read in. It's a whole line of the file. You break up the string into all of its fields and create an album object that contains all that information and return that to me, and I will assign that to something I'll call album, which is of type capital A album. Okay? And then what I'm going to do is I need to put that in my inventory. So in my inventory, I'm going to put it. How am I going to put it in there? I'm going to put it in by the album's name is the key. So I just say, hey, I have an album object that contains all my information now. So album.getAlbumName will give me the name. That will be the key. And the thing that I want to store relative to that key is the whole album object. Okay? So this just line by line reads the line, parses it. I'll show you how to parse it in just a second, to create an object, and then adds that object to this hash map that I'm creating that's going to store everything. Know this, live this, learn this, love this. You will do this for NameSurfer. Okay? So after I do all this stuff, I close off my file and I'm done, because presumably I should have read the whole file and put everything into my database, and I'm done. I do my little, exceptions with file reading just in case I had exceptions. So the only code you haven't seen so far is parseLine. What's parseLine doing? ParseLine is a string manipulation extravaganza. Okay, so what's parseLine doing? And I'll just go through this very simply. It's a lot easier than it looks. Basically, it's just a lot of indexing for strings. What I do is I say, hey, I got a whole string that has, oh, I erased it up here, but basically starts off with a bracket, has the name of the album, the name of Al, has the name of the band, and has some number that's an integer. So how do I break this up into sub-pieces that I can actually store in my structure? Well, the first thing I'm going to do is I want to pull out the name of the album. How do I find the name of the album? The name of the album starts after the first opening bracket. So I find the index of the first opening bracket and add 1 to it. That's the first character of the album name. How do I find where the end of the album is? I look for the index of the closing bracket. And so basically, if I take a substring from the start of the album name to the end of the album name, I pull out that piece of text that's just the album name, and I'm going to store that in a string called album name, which is just a local variable. Okay, so now I've pulled out the album name. How do I get the band name? Band name, I look for the index of the first bracket after the album name. Right? That's the critical thing. If I don't look starting after the album name, I'm going to read the album name again. So I look for the first bracket after the album name, which is at album name end plus 1. That will get me the index of the bracket where the band name starts, and I add 1 to that, which gets me to the first character of the band's name. And then I do the same thing over here. Whereas the end of the band's name, get the index of the closing bracket starting at the end of the album name. So I don't get the closing bracket for the album name, I get the closing bracket for the band name. So I start at the album name plus 1. So now I have the boundaries for the band's name. And so the band's name is just the substring I get in the line from the starting index for the band's name to the ending index for the band's name. Now the final thing I need to do, and this is the funky thing, that's probably the funkiest thing of this whole function, of this whole method, and it's pretty simple, which is to say that last thing that's on the line is actually an integer. So I don't want to pull it out as just a string. I need to actually convert that string to a real integer. How do I do that? Well, let me first find out where that number actually lives. Where do I find the number? I look for the number by finding the first space after the end of the band name. Right? The first space after the band name is going to be this index right here. The number starts on the next location. So if I take that particular location, right, after the end of the band name and add 1 to it, I now have an index that's the very beginning of the number of that numeric sequence. So what I want to do is I want to say pull out that numeric sequence as a string and convert that string to an actual integer. How do I do that? Well, the way I pull it out is I say take the substring of the line that starts at the starting position of the number stocked, right? That's what I just computed in the last line, was where that number starts. Because I don't specify an ending index for this substring, it goes till the end of the line, which means it takes all the characters, right? If this happens to be like 100 in stock, it starts at the 1 and takes the 1, 0, 0, takes that whole substring as this substring right here. And what do I do to that? There's a method that's a static method of our friend the integer class called parseInt. And so if you say integer.parseInt, you give it a string, it converts that string into its integer equivalent. So what it does, it says, hey, I'm giving you the number that's at the number stocked as a string. It says, okay, I'm going to parse that and turn it into an integer, and what I will give you back is something you can store as an int. Okay? So that's how we convert that last portion of the line from a string to an integer. We first extract it, and we get the integer. And then what are we going to return to the person who called our function? We're going to return a new album object. We're going to create a new album object where we initialize the album object to have the album name, the band name, and the number stock that we just parsed out of that line. Okay? So any questions about that? Standard thing you do in files. You pull out a line as a string, you break up that string using some string manipulation operations, however you want to break it up, and then you potentially create some object out of it so you can store all the nice things that you just extracted out of the string into nice little named fields. Okay? So this gives you an album object, and then back up here, that album object is getting returned by parseLine. We put those album objects into our inventory hash map indexed by the album name. All right? So any questions about that? Hopefully, if that's clear, nod your head. Good time. All right? And that's basically this whole, the real loading of the database. Now, the only other things that are going on here is we need to figure out our little interactors, right? So in our program, we have a label that asks for the album name, where the user can type the album name. So we put in a label, then we put in a text field that has a maximum size of 20, right? At this point, this should all be sort of old hat. We add the label to the southern region. We add the album name, which is just the text field that's going to take in the album name to the southern region. So we get those two interactors. We get the label and the text box. Okay? And the things we want to do after we set up the interactors is we say, hey, I need to display this stuff somewhere. I remember he told me, about 20 minutes ago, that if I wanted to actually have some canvas that could resize itself automatically when the user changed the window, what I needed to do was extend a gcanvas. I needed to create my own version of Campus and make it a component listener. That's the same thing I'm going to do here. I'm going to create something called a music shop display. A music shop display, which I'll show you the class for in just a second, is something that I'm going to store as my canvas as a local, as a private variable inside my class. And I'll just go ahead and say, after you put your little interactors on the screen, create your new canvas and add the canvas, just like I did before in the previous program. Now load all your inventory, so go read the file, do all that parsing, the funky stuff, set up the inventory. Add action listeners, because I want to be able to listen for events that actually happen on the buttons, and also add the text field album name as an action listener. Right? So it basically wires everything up. It says, put in the interactors, create the canvas that I'm going to draw stuff on, load the inventory into data, and get ready to listen for stuff. And then it's ready to go. It's not going to do anything until I get some events, but now it's ready to go. So load inventory you saw, parse line you saw. The only thing you haven't seen is, what do I do when an action's performed? Right? I don't have some button the user can press. All I have is the text field, so when they hit enter, I check to see if the source is the text field album name. If it is, what I'm going to do is ask the canvas to display the inventory of a particular album. How do I get the particular album? What I do is I'm going to say, what I want you to display, I'm going to give you an album object that's going to contain all the information you need to display. So I'm going to call display inventory passing an album object. How do I get the album object? I say, oh, text field, give me the text that's in you. It says, oh, here you go, here's what the user typed in. That should be the name of an album. I can use that name of an album in a hash map to look up the album object. So in my inventory hash map, I say get on the album name. And if there is an album object in my inventory hash map, that's what I'll get back. If there isn't, I'll get back null, and I'll go ahead and call display inventory with null, so it needs to know how to handle that. So all the action to do the display is going to happen in display inventory. So let me show you musicshop.display, which kind of pulls this final thing together. Music Shop Display extends gcanvas, just like you saw in the previous example with a little square. Implements component listener, just like you saw in the previous example. And it just has a little bit more complexity. The only additional complexity it has is in its constructor. As before, it needs to add itself as a component listener. That's boilerplate. But it says, hey, you know what? I'm going to keep track of the last album the user actually typed in, because when you resize the window, what I need is the information about that album to redraw everything in the window relative to that last album. So when I start off, there was no last album, so I set it to null. But as soon as you give me a real album, that's what I'm going to store in last album. It's the last album from the user. Okay? I'll show you a few things down here. Okay? So last album is basically just an album that I keep track of as an album object. The last album that the user searched for. I have a few constants that indicate for me how big things are going to be on my display. And I implement all the methods of a component listener. Again, the only one I care about is the resizing event. The other ones I ignore, and the resizing event I'll call update. If I call update, I'm going to display from my inventory the last album that I displayed. So if I had something in my display and my display got resized, basically all I want to do is redisplay that last album in the same graphics window. So update calls display inventory, or I can call display inventory directly from my main program to display something. And this is way more complicated than it looks, but I'll just briefly tell you what it does. It clears everything that's in the display in the gcanvas currently by calling remove all. Then it says, if you just gave me an album to display, the last album that I want to keep track of, the thing that I want to keep track of the display next time I get resized or whatever, is the album you just gave me. Because you just gave me a new album to display, so that's going to be the album I keep track of to display on resize events. If that album was not null, if it was null, I just clear the screen, I don't do anything else. If it wasn't null, it means that you had a real object in your inventory that was an album, so there's some work for me to do. What am I going to do? I'm going to ask that album for the number that are in stock, and I'm going to create a label that has album and the name of the album by and the name of the band, and I'm going to place it on the screen at a location that's centered based on the height of the current display. Okay? Then I'm going to have a for loop that displays squares that indicate, it shouldn't be dictating, it should be indicating how many are in my inventory. And I won't go through all the math because the math is not interesting. The only thing that's interesting about this is I have a for loop that goes through the number in stock and draws one filled in rectangle for every number in stock. What's the size of that rectangle? The length of that rectangle, it's called the bar length, depends on the total size of the window. So I look at the total size of the window and I divide by however many maximum squares I can display in the window, which happens to be 20, to get my size. So as the window gets smaller, this bar length is going to get smaller. And as window gets larger, bar length will get larger. So it depends on the size of the width of the window. And I do this in a loop, so basically to just draw out all the squares. And you can go through the math, on your own if you're interested in it, but the basic idea is the squares just change size depending on the width of the window. Last but not least, I write out another label that says how many are in stock, and where I display this on the screen depends on the height of the window, because I'm going to center. So as the height of the window changes, this will always recenter as well. Okay? And that's where all the action is. So when I run this program, right, it starts off not doing anything, and when I type in an album, let's do snakes and arrows because I think that's in there, I get a bunch of squares, and it's just sitting here. If I type in an album that doesn't exist, like cow, it clears the display and there's nothing to display. But if I happen to type in, let me do snakes and arrows again, something that actually does display, when I do the resize, it's resizing based on the size of the window because it knows what the last thing displayed was, right? It knows the last thing displayed was the album Snakes and Arrows and is storing that in its own local variable so that when I resize, it knows what information to redisplay on the screen to resize. Any questions about that? You'll do exactly the same thing in NameSurfer, and I'll give you all the code you just saw on Friday, so it will help you out a lot. All right, if you have any questions, come on down. Otherwise, I'll see you on Friday.